I think we are probably good to go. Those of you out there, if you're having a hard time hearing or something, just let me know. But that being said, I'll turn the floor over to Lana.
Okay, hi everyone. My name is Lana, and I am a senior here at Clemson, math major, and I spent last summer in Chicago working as a strategy and data intern at LivCor. So LivCor is a multifamily asset management company, and they have a portfolio of over 500 properties across the United States. So they have a business model similar to like your favorite HGTV show. So they buy properties that need a little bit of work. They do a full renovation on them. This normally includes new flooring, new roofing, washer dryer installation, and then they either sell the properties for an increased profit, or they keep the properties and collect the newly increased rent. They're kind of unique, and they have kind of a mission to leave communities better than they found them. So they create sustainable, inclusive, responsible communities and encourage people to treat each other like good neighbors. So LivCor is actually a Blackstone portfolio company. So Blackstone owns LivCor, and those of you who are familiar with Blackstone, they're an alternative investment management firm. So they invest in several different asset classes, such as private equity, hedge fund solutions, credit and insurance, and real estate. So LivCor falls under the real estate category, which they own over $319 billion worth of assets. As of Q3 2022, Blackstone as a whole owned a little over $950 billion in assets, which makes them the largest alternative investment management firm in the world. So they are made up of around a little over 200 portfolio companies, and have a little over 500,000 employees around the world. So what happens is investors invest their money into Blackstone, and then Blackstone kind of splits up their money between their portfolio companies. So LivCor gets a part of their investments from Blackstone. They use that money to buy the properties, and then LivCor manages the properties. It's in charge of selling them, buying them, and then in return, Blackstone takes a bit of the profit and uses it to pay back their investors. So as a strategy and data intern, I was a part of the data insight team. So their goal is to find and analyze market trends within the real estate industry to help assist leaders in making data-driven business decisions. They do this looking at all types of data, our property data and competitor data, to help establish a competitive advantage. So I thought this visual on the right was a good kind of way to explain data insights. So when we get the data, it's a lot, but it doesn't really, by itself, doesn't really tell much of the story. But once we put it into context and start to process it, we get some new information. And from the information, we can draw conclusions, also known as insights. And then the data insights team presents these to leaders to make the decisions, and they now have the knowledge needed to make the data-driven decisions. So as part of the data insights team, I had my own research project, which was, of course, motivated by the COVID-19 pandemic, which led to an increase in the amount of remote workers. So people were working from home, which means they weren't required to commute to any office locations. This kind of shifted priorities when choosing a place to live, because in the past, people lived downtown to have a short commute to work, but this came with a hefty price tag. So my team wanted to know if people were still placing value on downtown location over affordability. A little bit of a project overview. So the main question I tried to answer was, how does the expected commute time affect different market metrics? So I looked at three main metrics: rent, which is just monthly rent; rent growth, which is how rent changes year over year; and occupancy, which was how full our properties were. And I also had to determine like what I was gonna use as commute time, because we're looking at many different properties with thousands of residents, and they were all commuting to different locations. So I decided with my team to say commute time was the distance from a property to the center of a city, which is good and bad. I was looking at mostly big cities, so if you think about it, most people work downtown. So at the beginning of the day, everyone's commuting into the city. So that's what I use. And I started looking at LivCor's property data first. But we have about 500 properties, which wasn't quite enough data points to make a whole kind of market conclusion. So I also looked at market data, which was averaged by zip code. And when I put all the data together, all the markets together were a bit much. There's a lot of noise because each market is so different. So I actually split them up individually and just looked at the top 40 LivCor markets. So the first step was getting the data that I needed. LivCor gets some of their market data from a service called RealPage, which is an industry leader in data analytics. From there, data engineers at LivCor put the data into Snowflake, which is a cloud-based data warehouse. This is also where LivCor's property data is stored. So from there, I could write my own SQL queries to extract data. I could also merge tables, filter it as I needed. And the the hardest step of obtaining the data was getting the commute time, because that's not something LivCor had prior to my project. So I kind of had to figure out how I was going to have access to it. So I got kind of lucky, and someone on my team already had a Google script function that when given 2 points would ping Google Maps and tell you how long it takes to drive from one point to the other. So I put an example on the bottom corner. So I would pass it a zip code, and it would take the geocenter of that zip code, and it would find the distance to the center of New York City. So that's just one example, and so it's 3 times 71 minutes. But what's nice about this is I had all my zip codes, and I could just flash fill the whole column, which got my data really fast. And I also repeated this with the LivCor properties, like their addresses to the downtown. And now it was time to do statistical analysis, which is what I've been learning here at Clemson. I used R, of course, and I was looking at the relationships between commute time and each metric individually by city. So that was a lot of different relationships for a lot of different cities. So I just started basic, looking at the strength of different correlations to try to find out if there was even a relationship, and if there was, if it was positive, negative, how strong it was. And from there, I just fit basic simple linear regression models and looked at some elements like the significance of the estimated slope, standard error, and R squared. I quickly realized that my models were being negatively impacted by a couple of data points that weren't following the trend. So try to think of some possible reasons for this outliers. One was poor sampling. So for example, since I was looking at things on a zip code basis, it could be RealPage only had access to one property's data in a full zip code, which isn't really an accurate representation. Or zip code zoning. So a zip code could be mostly industrial and maybe have one property on the outside, which really isn't accurate either. And the third was calculation errors, which is kind of funny, because when I was calculating the drive time distances, it was sometimes like the middle of the zip code would be like on top of a mountain, and it like didn't know how to drive to the top of the mountain. So it would just say 0, which obviously was not true. So I handle these outliers using Cook's distance, which is basically a measure of how influential a specific data point is on a model. So if Cook's distance is really high, it has a really high impact on the model, which isn't necessarily a good thing, because you don't want your model to be too highly influenced by one specific data point. So I have a little bit of an example on the side. So each bar is a different observation. So there's around 90 observations, and the 5 in red are the most influential. After talking to my team, we decided it was best to remove these 5 data points. I mean, I repeated this process many times, but removal was the best option in this case, just because we weren't really looking for prediction. We were just trying to find a common trend. And next was displaying my findings. So I built an interactive Power BI dashboard, which is just kind of a data visualization dashboard to summarize my results. I unfortunately do not have access to this dashboard anymore, or else I would have shown you guys. But it allowed people to easily compare LivCor property trends to general market trends. I had them like side by side and scatter plots, so you could easily see like if LivCor was following the market, which is really interesting. I also built an ArcGIS map to kind of display where LivCor's properties are following in terms of drive time. So this is just Atlanta, for example. The darker colors obviously have the shorter drive times, and the red dots are LivCor's properties. So you can see most of them fall within like the 30 to 60-minute range, which was nice to know because now we know that LivCor has mostly suburban properties in Atlanta. Common trends. So the results were highly dependable on what market I was looking at, and that's mostly why I broke it down market by market, just because there was so much variation. But the first conclusion I found was as commute time increases, rent decreases. So that just means rents higher in downtown areas, which was already expected. The next conclusion was that as commute time increases, rent growth increases, which means that rents are growing faster in the suburbs. One possible reason for this is because demand is higher in the suburbs, because that would allow properties to charge more for rent. And then lastly, as commute time increases, occupancy rates also increase. So in the suburbs, the properties are fuller than they are in the city. This is nice for LivCor to know because now they know that there's possibly less vacancy risk in the suburbs than there is in the cities. So they can determine how risky their investments are when buying properties. Internship takeaways. So one of my most important lessons that I learned was data manipulation is time consuming. I spent probably half my summer just getting data in a way that I could put it into Power BI, mapping zip codes together, filtering what cities I wanted. It just took so much time. The second was I got to see a start to finish data analysis process. So I got to see from the idea to the data collection, to the cleaning, to analysis, to displaying results, and seeing how those could be interpreted when making business decisions, which was, we see a little bit of it in school, but not all of it. So it was nice to see like the whole process. And my last takeaway was to ask questions and be curious. So when I started this internship, I knew nothing about the real estate industry and like a little bit of a business background. So I really didn't know anything, but they really encouraged us to ask questions, learn about the markets, and just be curious about everything. So that is it. Thank you for listening. And I'll answer any of your questions.
So what would your team like?
My team was actually very small. They're very focused on building it out, but right now the team is 3 people, 3 data analysts. So they were very busy, but they were all very, very smart.
And how did you get this gig?
I just applied online, interviewed on Zoom, and
So in your findings, so you were saying occupancy as commute time increases, the occupancy increases. So
yeah.
did you take away from that people are willing to trade the bad drive for
Yeah.
cheaper living space?
Yeah.
It's interesting. And I have one more question. You know, you were doing the drive times and you said somebody had some Google thing up.
Yeah.
That would. Were those drive times commuted rush hour drive times or?
They were just general, they didn't have any traffic influence, actually.
Okay,
Yeah.
that's interesting, right? Because if you're an astronomer, you might
Yeah.
have less of a commute.
Yeah.
Right, so. Any other questions?
What sort of differences would you be seeing in like an inner city thing for rent and then something that's like an hour away?
So a good example is, Boston was actually, I had like a very, very steep trend. So in Boston, rent actually increases $30 a month for every 10 minutes you're willing to go out of the city. So it's kind of very drastic, but some markets it was little.
Did you see any difference between cities that had public transportation as a primary, like, you know, New York, everyone takes the subway in
Yeah.
versus Atlanta, everyone drives?
Yeah, no, because I was just really looking at drive times, so I didn't really see that one. I didn't really look into it, but that's definitely like a next step that could be.
What's your emphasis here at Clemson and how would you say like that helped you with this internship?
Yeah, so I am a statistics and computer science emphasis. The statistics definitely helps. Like I'm in like what is it, math 40/20, and then the time series and regression class. Those definitely helped, and then some of the computer science classes, just because the coding is kind of a big factor.
Other questions? Well, let's thank Lana again.
You were Chicago, right?
Yeah.
All right. Yes, I'm a massive technical expertise here. So I don't get anything down. Oh, let's see here. How do I add this? And that's you.
Yes.
All right, so I'll let you
Okay.
do your thing.
Perfect. Is it already sharing?
No, we can get back to that once you.
Okay.
Or do you know how to do that? It looks like you do.
Okay. Where's the?
Our next speaker will be Emma, who's going to talk about
Oh.
actually
Sorry. Yeah.
sort of two projects she worked on. So
Yes. Once I can get this. Yeah, here we go. Cool. Okay. Hi, I am Emma Grace Cowers. I am a junior here at Clemson University. I'm a math and a computer science double major. And so this past summer, I got to work at MITRE, pretty big company, not as big as Lana, but it has around 10,000 employees, based mainly in McLean, Virginia. I worked at their Quantico office in Virginia, so I relocated there for the summer. They're a technological solutions consulting type company. Their slogan is solving problems for a safer world. So they cover pretty much any project you can think of, working as a nonprofit organization for different organizations, different companies. But yeah, today I'm just going to talk a little bit about what I did, the projects I worked on, and what I learned. So this was my initial, I never had a corporate internship before. So based off of movies and like books I read, I kind of figured this would be my gig, getting coffee for people, running errands. You know, I thought it would very much be something I could kind of throw in a resume, but not actually have done anything, but it was something to say the least. But that was all thrown out as soon as I got to MITRE. They're very passionate about people and very passionate about finding stuff that you're passionate about, because therefore you're going to do your best work on something that you are passionate about. So this did not happen, which I was very, very happy because I actually got to learn stuff, which was amazing.
So yeah, so this was my first project. So my branch, which was in Quantico, worked mainly for the Marine Corps. A lot of our employees were actually ex-Marine Corps. So I got to hear a lot of cool stories. My supervisor was ex-Marine Corps. He had just got retired like a year before. So very, very fresh out of that. And his idea, what he wanted to do was create an efficient and automated cyber assessment tool for the Marine Corps that evaluated weapon systems and defense critical infrastructure. And so basically he wanted, there's a gap between military personnel and the technological people that are taking care of cyber assessment. And so what he wanted to do was create some sort of interface that took minimal training for military personnel to understand, that would prioritize vulnerabilities within their weapon systems, because nowadays we very well know that software is a part of pretty much everything that you do. And so their machines obviously now have a ton of software implemented into them and therefore are susceptible to cyber attack. So the goal with this would be to take each weapon system or defense critical infrastructure and be able to show them their vulnerabilities and show them how to quickly remove them. This was very much the beginning of the project, like very, very beginning. So a lot of it was, first of all, just understanding the problem space. Currently, there's not a uniform way to assess military vehicles, systems. And a lot of times whenever they are assessing them, they're restarting from scratch every single time, rather than recognizing similarities between systems and therefore not duplicating efforts by seeing those similarities and not having to reassess it every single time you create a new system. So for example, like if there was a tank and then a newer tank, and within them they had a couple similar components, instead of having to reassess all those components within the new tank, you would just assess the components that have not already been assessed, if that makes sense. So currently there's not a database to kind of have those similarities. So that's one of the problems. But yeah, this was just, first of all, kind of understanding. I've never worked in the military, understood the military. Honestly, this was my first big introduction to cyber assessment. So that was the first thing, just kind of understanding, talking through things. And then, so we were working for the Marine Corps, that was our sponsor. So they gave us a framework or an idea of how they wanted to model this cyber assessment tool. And so my first task was to model that. We initially used BPMN, which is business process modeling notation. It looked a little something like this. So this was based off of a document they gave us. And through the software, it was Cameo Enterprise Architecture. I began modeling it as best I see fit. They gave me a lot of flexibility with this. A lot of it was just getting quote unquote pen to paper. I had a colleague who told me the worst thing you could have was a blank page, because honestly, initially going into this internship, I was very hesitant to speak out a lot because I thought I was just the intern. I also, on my team initially, was the only woman as well, and the rest were 40-year-old military men, a lot of them. So it was a little intimidating at first, but I very much learned to speak my mind, to put my thoughts on paper, to express those. So all of this was initially me without any editing. So I basically took each process, broke it down into further processes, just to kind of have a flow of understanding of how we wanted to go about building this. So if you were to click on phase 1, here, let me see if I can move this. If I can move this. Okay, I can't. Okay, it's fine. Yeah, so if you click on phase 1, this was a branching between passive reconnaissance, active reconnaissance. This is another example. If you were to click on reconnaissance, I don't know why that's so small, but after clicking creation of the CAP, then would branch off into this. This is how they wanted to prioritize attacks. So basically, if whenever you have a cyber assessment, there are gonna be more vulnerabilities than you have time at the time to deal with, because frankly, you're always gonna have certain vulnerabilities. But the goal is to prioritize them based off of them being mission critical and that they would make your mission fail. And so you prioritize the ones that could hurt your mission at that point in time. And then I just did blue. These were just thoughts. This wasn't what was distinctly within the framework, but once again, they really encouraged me to be curious, to just put pen to paper, just to think things through. And so that's exactly what I did. All that to say, if you would go back here, I did all of that for all the different phases, for all the different things. So it took me a very, very, very long time. And then I get it all done. I'm really proud of it. I'm really excited. I'm like, wow, I really contributed something. And my supervisor comes up to me and says, hey, Emma. So I've really been thinking about like what we need for this assessment tool. And I'm wondering if this language, this BPMN, is the right language for us to use. And I was like, okay. He's like, can you do a little research on that for me? I was like, okay. So I spent a day, did some research between BPMN and SystemML. And I had to put my bias aside and legitimately look at the facts and what we were trying to do. And so I wrote like a little recommendation report and sadly recommended SystemML. He talked to a couple other people, decided we would be going to SystemML. And so I was like, well, darn, all that work I put in is not going to be used. But it was still, they really encouraged me. It was still really good, first of all, for me to understand what was happening. It was also really good because as we brought other people in who were more experts on SystemML, as they were starting to walk through it, they actually used my modeling as kind of a basis as they moved forward. So it was still, once again, a good kind of brainstorming exercise for the team and for me. And the reason we chose SystemML looks a lot more at systems of systems and how they work together. That BPMN is a lot more connecting tasks and how we want to do them. And so with ours, weapon systems are a system of systems, meaning there's so many different components. You have a screen system that you can, touch along with another system that's moving the actual tank, another system that's, giving you ability to shoot. And so it's a lot of systems working together. And so having that system of systems, using SystemML to model that was important. And then they also really encouraged me to ask any questions. Once again, this was very much discovery phase. So we were talking, I had the opportunity to talk to a bunch of SME system matter experts from all across the company on different aspects of the project that we were looking into. And they just really encouraged us to ask as many questions as we want, which if you know me, I'm very good at that. So I very much took advantage of that. And then finally, I told my supervisor in the future, I'm hopefully looking into leadership of some sort. And so he kind of took me along the task project management on his side of things. So how he prioritized tasks, how he enabled the team under him. And it just kind of, he would come in every day, kind of throw up his thoughts on me every single day, how he wanted to do things, and we would talk it out. And so it was really, really cool to kind of be, I guess, not the go-to person, but anyway, I like talking ideas out. So that was really fun. About halfway through with discovery, if you ever are at the beginning of a project, that will take a very long time. You will find sometimes there's some lull periods as you're waiting on either more people, if you're working with the government ever, it takes so long to respond. It's actually terrible. So waiting for people to respond, that's another thing. So there was a little bit of a lull. And so I was like, I want another project to work on. And so this second project that I got to work on, it was already a lot more established. So I was actually working more so in development. And so the goal of this one was to create a GUI application to identify and understand more information about targets within a military operation. So basically what this was, it was a, what it was going to be purposed for was in meetings with military personnel. when they're talking through strategies, what they would be able to do is actually simulate using GPS, movement of, military machines, troops, tanks, planes, whatever, boats, whatever it may be. And so that way they could actually visually show that happening. And so I was tasked with creating play pause button, power on and off button, and loop on and off button for this application. I get there and I wanted to do something else, so I was excited about it, but I didn't know the coding language they were in. There was thousands of lines of code already established that I had no idea what was happening. And it was a big learning curve, but it was really, really cool to kind of see how to jump over that learning curve, which I'll talk a little bit more about in a sec. The first issue we ran into, which is, I think all math majors have to take a little bit of computer science, right? Okay. Well, I'm sure all of you are familiar with bugs. I never knew you could get so much bugs simply with just downloading stuff and trying to get software to work. Because we were downloading, we were using virtual machines and uploading and using a lot of stuff within terminals. A lot of we were building an RPM image, which is basically a more complicated version of a zip file. And just getting the software to work, just being able to do that without even me starting coding and like duplicating the environment to my computer. And of course they give it was a good computer, but the intern computers versus the employee computers, it would run a lot slower. So we spent a very, 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 very long time just trying to get the environments working before I even started coding. So that got really frustrating, but I also recognize that it's a part of starting up any development period. It's part of being coding anything. And it definitely made me research a lot on my own to try and figure stuff out and also not be afraid to ask for help. Had some really smart people helping me out, and they were very, very kind, helping me out all the time. So I really appreciated that. But once we actually got that working, the coding actually went pretty smoothly. This was the map application. I was actually, so a lot of this was already there. All I did is I added this little tab right here. It was using a coding language called Vue. And I added these buttons and they switch whenever you click them, you know, on and off, like pause, loop on and off. And by the end of it, we were able to connect it to a mock simulator. So they didn't have, on their end, there were still some other components that they needed to build in order for the simulation to actually work. But there was a mock one that we were able to connect to and send some messages to it that you could see via the terminal. So once they get there, that component, I had to leave before that component of it started working. But hopefully it should be a smooth transition once they get that working. So that was really cool because I learned a new language, worked with a bunch of different software. So very, very interesting. A couple other opportunities, like I said, I got to talk with a ton of people all across MITRE. Super, super smart people. I swear everyone has at least 2 degrees because I'm actually going to plug MITRE in. If you're looking for someone to pay for your next degree, even if it's a PhD, I think they do, because I know one guy had like 5 masters because MITRE just kept paying for his degrees, and they give you paid Fridays off to study. Anyway, so a lot of people with a lot of knowledge, always curious, always wanting to learn. So I got to talk to a lot of really cool people. I built a robot at one point. We were going to do an intern challenge, but it didn't end up happening. But I've never really done any technological stuff with my hands. So it was really, really cool to do that. Visited McLean. I worked at a very small branch, which I liked because I got to know people. But McLean is their main branch and it is like a college campus. It's actually insane. So they have a lot of really cool development opportunities for people just starting there. They did learning tracks as well. So I chose the AI learning track, and we, as our final project, or we had a couple lessons, just kind of learning a little bit about it. And then our final project with a random group was just to detect phishing URLs using AI and linear regression models. It was kind of similar to what she was saying. We took out outliers and looked at correlations, and so a little bit of statistics in there as well. Okay, and so these are some valuable life lessons. This stands for the military uses an obnoxious amount of acronyms. I swear it was a whole different language. I didn't understand why they kept using it when they could have just said the words, but they did. And then Miss Carla and Miss Karen, they were the sweet front desk ladies. I swear they wanted me to gain the intern 15. Didn't have a problem freshman year of college, but I think they were really trying the hardest because they were like my moms while I was there because I relocated. So they were constantly giving me food. It was great. I wasn't gonna complain. But in all seriousness, I learned I never want to be the smartest person in the room. Someone gave me this advice. It said if you are the smartest person in the room, leave, because you're never going to learn anything there. Because like I said, at first I was very intimidated by the amount of smartness I was surrounded with. But in reality, I learned it was just an opportunity to learn a lot. Secondly, collaboration. I say that 3 times because it was so important. I didn't know anything of what I needed really. I mean, I knew the basics of coding and I knew how to think through problems, but the actual technical work of what I needed, I didn't know anything. And I learned that from the people I was with and by asking questions, and not being afraid to collaborate with people, because if you're there, they're willing to help you and they want to help you grow. This was actually advice my supervisor gave me at the end of my time. He said, search for solutions, don't just wait for them. And like I said, we did have some lull periods. And so I did constantly ask for tasks to try to stay busy, but sometimes, frankly, there wasn't any tasks to do. And so he said, in those times where there's waiting, instead of waiting passively, wait actively. We have a problem space, you understand what the problem is. Is there anything you can do to look into it, that you can be talking to people, that you can be looking for new ideas, and that kind of thing. Curiosity gets you farther than intelligence. Like I said, all these people, this was a big shock to me. No one knows what they're doing when they initially go to a job. Like seriously. They learn from the people around them. I mean, they obviously have competency to get the job. And I mean, if all of you are doing a math degree, you have some level of competency, because it's not an easy degree whatsoever. But all these people were constantly on new projects, constantly learning new things. There was one guy, we had 2 teams, automation team, modeling team. He had never done modeling before, but my supervisor was like, okay, Nate, you're going to be doing modeling. He said, okay, and he just started learning, and he had been in the field he was probably 40, 50 years old. So these people are constantly learning, constantly getting degrees, apparently. And then lastly, I learned I am capable. Imposter syndrome, I'm sure a lot of you have heard of that, and a lot of you are aware of that and have experienced that. But this really encouraged me, once again, that I don't have to have all the qualifications going in. But if I'm curious, and if I'm willing to collaborate, if I'm willing to search for solutions, if I'm willing to put in the hard work, then I'm capable of whatever job I get to. So with that was my internship at MITRE. Do you have any questions? Yeah.
Any questions? You need to ask your question again.
Oh,
Yeah.
I think you mentioned that she was computer science and mathematics.
Well, I mean, how did it
But, how
fit
did it-
in, with,
Okay, yeah, so the math, I will say, actually, there was, I can't even remember exactly what it was, but the ideas and the methodologies that I use in mathematics, I think I even pulled some algebra somewhere in there at some point. I don't remember for what, or I think maybe we're talking about for theory or there were some smart people who sometimes would just come in and talk about super abstract stuff, which is awesome. But a lot of the concepts, like I said, we were in discovery phase, so we were trying to think through things, understand things. So there wasn't necessarily hardcore mathematics in that component, but the way I thought through things and the way I had to work through problems was. And then obviously when I was coding, that's computer science and being willing to learn.
I have questions.
Yeah, how'd you like get this opportunity and how'd you apply for it?
Yeah, so this was, I think, the 22nd internship I applied to last year. And it was around February, January. So I was like freaking out because I really needed one. But my friend, her mom was the college coordinator for MITRE. And I just sent her my resume. And then next thing I know, I was getting a text from my supervisor like, hey, welcome to the project. So it was ironically very easy. They're honestly very easygoing, and especially for their interns, it's a lot easier to get full-time job there if you have an internship going into full-time versus, I don't know, I think most people got interviewed. I don't really know why I did it, but it was a really weird situation, but connections, I guess.
Other questions? Well, thank you very much. It's great. Thank you all. Math Club, obviously, next week will be the last week of the semester. And we will have another talk then. And don't forget about the math end. If you've got the inclination, please be there. It should be a lot of fun. Otherwise, you all have a good weekend, and we will see you next week.
Oh.
Oh, I've got
You can say, Quantico.
Quantico. There we go. How about that? Any other questions from out there in either world? Again, oh, and remember, we have one rule of Math Club, all the seats that have to be gone, so take it home, be the hero of your dorm.